The discovery of a never-before-seen comet has captivated both professional astronomers and sky-watching enthusiasts, arriving with almost no warning as it sped inward from the outer reaches of the solar system. This intriguing object, now designated C/2025V1 Borisov, sparked immediate curiosity because it shares a few surface-level similarities with the infamous interstellar visitor 3I/Atlas. That comparison alone has caused excitement, speculation, and even misunderstandings about whether this newcomer might also have originated from outside our solar system. But despite the rumors and some suggestions circulating online, the evidence strongly indicates that this comet is not interstellar. Instead, it is almost certainly a native of our own cosmic neighborhood, following an unusual but technically bound trajectory around the Sun. Still, the circumstances of its discovery and the unusual nature of its orbit have created the perfect combination of mystery and scientific interest. C/2025V1 was first spotted on November 2nd by the well-known amateur astronomer Gennady Borisov, who is based in Crimea. Although he is considered an amateur by title, his contributions to observational astronomy are far from ordinary. Borisov has built his own advanced telescopes and has demonstrated exceptional skill in locating faint, fast-moving objects. His name became internationally recognized in 2019 when he discovered the second confirmed interstellar object ever observed, later named Comet 2I/Borisov. That earlier discovery placed him in the history books alongside the discoverers of Oumuamua, the first recorded interstellar visitor. Because of this, any new object found by Borisov naturally attracts attention, and the fact that this latest comet arrived with some unusual orbital characteristics encouraged astronomers and commentators to look closer. The timing of the discovery is fascinating. The comet was found only days before it was due to make its closest approach to Earth, meaning that for most of its inward journey toward the Sun, it went unnoticed. This is not entirely surprising. Space is enormous, and small objects with low reflectivity can escape detection until they move closer to the inner solar system. As reported by Orbital Today and other tracking organizations, C/2025V1 will reach its closest point to our planet on November 11th, passing at a distance of around 64 million miles, or about 103 million kilometers. To put this in perspective, that distance is more than 270 times farther away than the Moon. So even though it qualifies as an interesting near-Earth object in astronomical terms, it poses absolutely no danger to our planet. Following this, the comet will continue toward its perihelion, the point in its orbit closest to the Sun, scheduled for November 16th. One of the interesting features of C/2025V1 is its faintness. With an apparent magnitude of around 13.8, it is far beyond the threshold of naked eye visibility. For comparison, the faintest stars the human eye can detect under perfect dark sky conditions have a magnitude of about 6. A magnitude of 13.8 requires either a powerful telescope or high-quality stargazing binoculars to observe. Still, for dedicated astronomers, this brightness level is manageable. As of its current position, the comet lies within the constellation Virgo, a large and prominent region of the sky. Observational data from platforms such as the SkyLive.com show that the best time to spot C/2025V1 is shortly before sunrise, when Virgo is positioned favorably in the pre-dawn sky. Anyone hoping to catch a glimpse will need both patience and the right equipment, but the knowledge that they are watching an object newly discovered and scarcely seen by anyone else adds a level of excitement uncommon in typical backyard astronomy. The name Borisov, attached to the new comet, naturally reminds many people of the interstellar Comet 2I/Borisov from 2019. That earlier object was a genuine alien traveler, an icy fragment ejected from a distant star system long ago. It likely spent billions of years wandering through interstellar space before accidentally passing through our solar system. Its speed, composition, and hyperbolic orbit immediately identified it as an interloper from beyond the Sun's gravitational influence. In the years since its discovery, interstellar objects have become a subject of intense scientific interest, and the arrival of 3I/Atlas in 2025 only fueled further speculation. 3I/Atlas, spotted a few months before C/2025 V1, also traveled on a hyperbolic trajectory and displayed unusual physical behavior, leading to debates about its structure, whether it was fragmenting, and what its origin might reveal about distant star systems. Because of the similarities in timing and certain superficial orbital traits, some individuals began drawing comparisons between C/2025 V1 and 3I/Atlas. One of the loudest voices in this conversation was Harvard astrophysicist Avi Loeb, well known for his bold hypotheses and interest in extraterrestrial phenomena. In a blog post, Loeb described the new comet as nearly interstellar, a phrase that quickly spread across social media and discussion forums. But what does that phrase even mean? The concept of a nearly interstellar object might sound dramatic, but in astronomical terms, it is not particularly mysterious. It simply refers to an object whose orbital eccentricity, its measure of how stretched out its orbit is very high, approaching the boundary between a closed, elliptical orbit and an open, hyperbolic one. Interstellar objects travel on hyperbolic paths because they are not gravitationally bound to the Sun. C/2025 V1, however, does not cross that threshold. Its orbit is elongated and unusually straight, but still closed. This means it is bound to the solar system and therefore native to it, even if its path resembles interstellar motion. Eccentricity is one of the fundamental properties used to classify orbits. A perfect circle has an eccentricity of 0. A typical comet with a stretched, oval-shaped orbit might have an eccentricity of 0.7 or 0.9. A parabolic orbit, right at the escape boundary, has an eccentricity of exactly 1. Anything greater than 1 is hyperbolic and indicates an object that will never return. The orbit of C/2025 V1 is highly elongated, with an eccentricity very close to but still below 1. This suggests that the comet likely comes from the Oort Cloud, a distant spherical shell of icy objects surrounding the solar system. Comets originating from the Oort Cloud can have extremely stretched orbits, often taking hundreds of thousands or even millions of years to complete a single circuit around the Sun. Their long, slow movements in the outer regions make them difficult to detect until they rush inward on their brief journeys near the Sun. Another detail that contributed to the speculation is the comet's lack of a visible tail. Comets are traditionally depicted as bright objects with long, glowing tails of dust and gas trailing behind them. But not all comets behave this way. Some produce very faint tails or temporarily appear tailless due to the angle of observation or low levels of volatile materials on their surfaces. Both 3I/Atlas and C/2025 V1 have appeared in early images without clear tails, causing some viewers to overinterpret the absence. However, professional astronomers note that many faint comets only develop noticeable tails as they move closer to the Sun. For C/2025 V1, its low brightness and possibly limited volatile content may explain its subtle or absent tail. A missing tail does not imply interstellar origins. It simply reflects the comet's composition and current activity level. The comparison between 3I/Atlas and C/2025 V1, though scientifically interesting, is ultimately superficial. Their eccentricities differ significantly, and the orbital solutions, mathematical calculations of their paths, show that C/2025 V1 is gravitationally bound to the Sun. It is also moving at velocities typical of long-period comets. Interstellar objects, by contrast, travel much faster because they are not restricted by the Sun's gravitational domain. Additionally, spectroscopic studies, though still early in development for this comet, indicate compositions typical of Oort Cloud comets. These objects are made of frozen water, carbon dioxide, carbon monoxide, and other volatile compounds that sublimate when heated. So far, nothing in the chemical data suggests anything exotic or unusual enough to imply an interstellar origin. What we are witnessing with C/2025 V1 is a fascinating but natural event, a long-period comet making a rare visit to the inner solar system. Its late discovery, faint appearance, unusual orbit, and connection to a famous discoverer have combined to create a story that feels dramatic and mysterious. But in reality, this comet represents a chance to observe one of the billions of icy remnants left over from the formation of the solar system. These primordial objects offer scientists glimpses into the early conditions of our cosmic environment, preserving materials unchanged for billions of years. Every incoming comet provides an opportunity for new data, improved models, and deeper understanding of how planets, moons, and smaller bodies formed. In the days surrounding its closest approach and perihelion, researchers will continue gathering observations. Amateur astronomers equipped with good telescopes will attempt to photograph it, capturing faint wisps of its coma. Observatories will measure its brightness curve to determine whether it becomes more active as it nears the sun. Orbit analysts will refine its trajectory with each new measurement, improving predictions for its future path. It may fade quickly after perihelion, or it might briefly brighten if sublimation increases. Regardless of how long it remains visible, C/2025 V1 represents another reminder that our solar system is dynamic, full of objects still waiting to be discovered. Even though this comet is not a threat to Earth and not a visitor from another star, its arrival is meaningful in a broader scientific context. It highlights the power of skilled observers like Gennady Borisov, whose dedication allows discoveries that even large observatories sometimes miss. It underscores the importance of monitoring the sky for faint, fast-moving objects. And it reminds us that even in a technologically advanced age, the cosmos still holds surprises, some subtle, some dramatic, but all contributing to our ongoing effort to understand the universe we inhabit.